Hello wonderful person, this is Anton, and today we're going to be talking about blue large amplitude pulsators, also known as BLAPs. This is a completely new discovery that we know nothing about, and we're going to be discussing this idea in a little bit more detail using Universe Sandbox. Anyway, welcome to What the Math. So, for years now, scientists have been using a telescope known as OGLE, also known as Optical Gravitational Lensing Experiment, and looking for exoplanets. It's actually been looking in one sort of space, or not space, but one direction of space for several years and has been looking at billions of stars at the same time. And while looking at those stars, it's discovered some planets, it discovered some other anomalies, but then it's also discovered some really cool, rare events and things. And one of those events is what we now call BLAP. Not a best name, but it's cute. And it refers to blue large amplitude pulsators, which are basically these very large blue stars. Now, this is serious, it's not as large as we're talking about here. What we're talking about would be something on a scale of Rigel. So we're going to place Rigel somewhere next to these beautiful stars. Although this might cause a bit of a supernova, so we might have to slow down time, just for the sake of things not exploding just yet. So there's Rigel. So this is just a regular blue star, and blue usually means that it's very, 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 very hot. But what's unusual about these unusual stars known as BLAPs is that they pulsate. Now, many stars pulsate. There's actually quite a lot of different types of pulsation, and it's quite a well-studied phenomenon. Some stars, for example, pulsate because they're rotating. So if I were to go in here and change the rotational speed to, like, I don't know, let's just say 3,000 kilometers per second, and accelerate time just a little bit, you would see that as it rotates, it might actually once in a while point with a different side of the star that's a little bit darker, and this would create dips in luminosity. It would once in a while be darker, so it would maybe do a bit of this, it would decrease in the luminosity, and then it would increase in the luminosity again. Actually, to change the actual brightness of the star, I need to change the temperature. So there you go. So maybe something like this, periodically. And sometimes the star might actually do other types of pulsations. Like, for example, it might actually heat up the material on the surface, making it more transparent or increase the opacity. And because of the opacity increase, it would actually release more energy. And then once in a while, it would actually cool down and release less energy. So once again, it would look something like this. More energy, less energy. So there's a lot of different types of pulsations, but this one that we've just discovered is very, very unusual and somewhat unknown to us. It basically goes through stages of about 20 to 45% increase in luminosity. So basically, from a star going let's look at the blue star. From star being this way to being this way. Now, it doesn't look more luminous, but it's actually a lot more hot. To make it more luminous, I actually do have to increase luminosity a little bit, but the best way to do it is actually this way. So from this to this, from this to this, from this to this. And what's really unusual about BLAPs is that this happens every 20 to 30 minutes. Normally, pulsations happen in periods of days, months, or even years. This one is super fast. It goes through these stages in essentially just half an hour. And we have no explanation to why this is happening. So let's just do this to our sun, for example, just so you can see how extreme this is. It's as if, let's go in here and just find our solar system. It's as if our own sun went through these stages, and we're actually going to decrease time here just so that you can see the effects. Our own sun went through these stages every half an hour. So right now I'm going to increase its luminosity by about 20%, and I'm going to decrease it by about 40%, just to show you how much influence this would have. So here we go. We're going to increase the temperature to about 6,500 degrees, and you can see that it changed its appearance. And for about 15 minutes, it's going to stay this way. And let's actually see what happens to our beautiful planet Earth. And you'll see that as this changes so quickly, the temperature is going to start climbing dramatically. So we're going to get all kind of fried and boiled on the surface within a few minutes. And you can see the plant life already disappeared. It's no longer green. Now this is longer than half an hour, of course, but we're going to now decrease this by the same amount, by about 20% from the original value, making the temperature of the sun much lower than it used to be. So now it's going to be only about 4,000 degrees Kelvin. Maybe a little bit more than that. Ooh, okay, our sun is going funky there, and it disappeared. Okay, well, let's try this again. That was a mistake on my part. So let's try this again. Decrease it by about 20%, making it approximately 4,800 degrees Kelvin. And let's look at the planet Earth and see what happens to it. And just like that, our beautiful planet is now basically frozen. It's minus 87 degrees Celsius here. But because this would be happening so fast, basically every half an hour, the average temperature on those planets would not really change that much. But the problem, of course, is that you would be faced with these strange anomalies of temperature changing from like 5,000 degrees to 7,000 degrees, back to 5,000 degrees, pretty much every half an hour. And this unusual pulsation of a star would really create some unusual effects on the surface of a planet, because it would basically be going from the frozen stage to then warm and superheated stage, and then back to frozen stage again. And especially if those planets actually do have liquid water, it means that the water would be frozen and heated up really fast. And what's really interesting is that we've discovered at least a dozen of these types of stars that seem to have these types of properties. And if there are planets around them, this would be a very interesting place to visit and to discover what actually happens on those objects. So if the temperature changes so dramatically every half an hour, it would only we can only imagine what kind of planets and what kind of objects actually reside in these systems and what happens on their surface. Now, unfortunately, that's really all we know about these stars so far. We know that they exist, we know that they're there, we've seen their unusual patterns, but we have no explanation for why, for how, and for what's going on inside of them. What's really cool, though, is that we actually discovered them completely by accident, because we weren't even looking for these stars. We were looking for planets. And just like that, we discovered these objects known as BLAPs. Now, one day we'll be able to see them and discover the secrets of these objects, but for now, we can only speculate about what's really happening there. And once we know more, I'll post another video explaining what's going on there as well. Anyway, thank you so much for watching. Hopefully you learned something from this video, and if you did, don't forget to subscribe, share this video with someone who enjoys watching space videos, and come back tomorrow to learn something else. I'll see you guys tomorrow. Space out, and as always, bye bye.